Hi, so in this video I'm going to go through question 4 on Math 2008. So in this question we're given this diagram. So here the points P and Q are at P0 and 0Q. And they want us to show that the equation of the circle C, which passes through the points P, Q and 0, so this circle here, has this equation. And then they want us to find the center and area of C. So the general equation for a circle is x minus a squared plus y minus b squared equal to r squared. And we also know that the points P, Q and the origin lie on the circle C. And so if we substitute these points into our equation, so here I've just put x equals to P and y equal to 0 in the equation star to get the first equation, and then similarly for x equals 0 and y equal to q, and then for x and y both equal to 0. And so we see we've got three equations for a, b and r, and so we can treat these like simultaneous equations and solve for a, b and r. So first, if I do equation 2 minus equation 3, then we see we can eliminate a and r. And so if I rearrange this and solve for b, then we get, by taking the b squared onto the right, we have this, and then we have this line from taking square roots of both sides. And so we see that we get either q is equal to 0 if we take the negative root, or q is equal to 2b if we are taking the positive root. But we know that q is positive, so greater than 0, and so this first option isn't possible. And so we must have that q is equal to 2b, or b is equal to a half q. And similarly, if I do equation 1 minus equation 3, then we see we can eliminate b and r. And so if we solve this for a, we get either p is 0 or p is equal to 2a. And like before, we know that p is positive, so we can't have p equal to 0. So p is equal to 2a, or a is equal to a half p. So now we've worked out a and b, so we just need to find r. So if we use equation 3, then substituting a is equal to a half p and b is equal to a half q into equation 3, we see that we get r squared equal to a quarter p squared plus q squared. And so putting a, b and r squared back into our equation for c, we see that the equation for c is going to be this. And from here, immediately we can work out the center of c, right? So the center is just going to be a half p, a half q. And we also want the area, so the area is just pi r squared, and because we know this here is r squared, we have that the area is a quarter p squared plus q squared times pi. So now we just want to see if our equation for c is the same as the one that they want. So this is the equation we got, and this is what they have. So let's just expand ours and check if it's the same as this. So this is what we get if we expand our equation. And we see that we've got a quarter p squared and a quarter p squared, which cancel, and same for the q squareds. And so we see that our equation is the same as their equation. Okay, for part 2, they want us to show that the area of circle C divided by the area of the triangle OPQ is greater than or equal to pi. So in the last part, we worked out that the area of the circle was a quarter p squared plus q squared times pi. And for the area of this triangle, well, if we use the formula for the area of a triangle, which is a half times base times height, the base is p and the height is q, so we have the area of the triangle OPQ is just a half times PQ. And so the ratio, the area of C over the area of OPQ is just a quarter p squared plus q squared pi over half pq, which we can rewrite like this. So we want to know if this is greater than or equal to pi. So if we want to know if this is greater than or equal to pi or not, we're going to want to know if p squared plus q squared over 2pq is greater than or equal to 1. And this is the same as saying, is p squared plus q squared greater than or equal to 2pq? And there is quite a standard proof to show that this is true. Because if you note that this is the same as p squared minus 2pq plus q squared greater than or equal to 0, and this is p minus q squared, then to show that this inequality is true, we can say, well, we know that p minus q squared must be greater than or equal to 0 because it's a square, and expanding the brackets gives us p squared minus 2p minus 2pq plus q squared is greater than or equal to 0, and then adding 2pq to both sides gives us the inequality that we want. Note that to actually do this proof, I didn't start from here and show that this was the same as this. I started from the results that I knew and then proved the thing that I wanted. So don't start a proof with the thing that you're trying to prove. Okay, so now we've proven this inequality, then we can basically work backwards through this to show the result we want. So first dividing through by the 2pq, and then multiplying through by pi, and so we get the result that we want. Okay, now for the last part, they want us to find the angles OPQ and OQP, so this one and this one, if the area of C divided by the area of the triangle OPQ is equal to 2 pi. So we worked out what this ratio was in the last part. So we said it was p squared plus q squared over 2pq times pi. And so now we're saying that this is equal to 2 pi. And so we can cancel the pi's. So if I multiply both sides by 2pq, then we see that saying that this ratio is equal to 2 pi is equivalent to saying p squared plus q squared is equal to 4pq. So I guess we'd quite like to know p and q, because then we'd have the sides of this right angle triangle, and so we'd be able to use trig to work out the angles. So if we try and find p and q from this, so let's rearrange. We can rearrange to get this, which is like a quadratic, but we've got two variables, or two unknowns, and it's not one we can easily factorize. But, well, q is just a number, right, which represents the height of this triangle. So we can just treat it like a number and then use the quadratic formula. So maybe if I rewrite this middle term first, then you can see that this is like a quadratic in p. So we've got a p squared term, a p term, and this q squared is just a constant for us. So if I use the quadratic formula, we'll get this. So this minus 4q would be like the b that you usually put in your quadratic formula, and this q squared would be like the c. So we've got this, and we can simplify. So we've got 12q squared inside the brackets, and 12 is just 4 times 3. So taking the square root of the 4 and the q squared, then we end up with this, and we can factorize q. And so we see that p is equal to 2 plus minus root 3q, and whether it's the plus or minus here is going to depend on if the p is greater than q or if p is less than q. So if p is greater than q, then we take the positive root here, and if it's less than q, we take the negative root. And so now we have a relationship between these two sides, and so we can use tan to work out these two angles. So we have that tan of phi is p over q, and tan of theta is q over p. So we can see in this first case, when we have tan of phi, well, that's just p over q. So dividing through this by q, we get that tan of phi is 2 plus root 3. And then tan of theta is q over p, so it will just be 1 over p of q, i.e. 1 over 2 plus root 3. And if you try to rationalize the denominator on this, you see that actually this is just equal to 2 minus root 3. And similarly for this case, when p is less than q, so for tan phi, we're dividing through by q to get p over q. So dividing through by q, we get 2 minus root 3. And then tan of theta is just 1 over that. So 1 over 2 minus root 3, which is 2 plus root 3. And it's enough to just leave it like this in terms of the tan thetas and tan phis. Arctan of 2 minus root 3 is actually pi over 12, and arctan of 2 plus root 3 is 5 pi over 12, but they didn't actually expect you to know this. So you can just leave your answers like this, or else you can just say tan theta is theta is equal to inverse tan of this, and so on.